This week, cracking BIOS passwords, Stackwarp, important secure boot updates, Fortinet's patching the patch, and more. Stay tuned. Below the surface, coming up next. Welcome to Below the Surface. It's episode number 67, being recorded on Thursday, January 22nd, 2025. I'm Paul Asadorian, joined by a mixture of coworkers and podcast friends. Mr. Vlad Babkin is here. Vlad, welcome.
Hello.
Mr. Chase Snyder is here.
Hello.
And Miss Mandy Logan is here. Mandy, welcome.
Why, thank you. It's my first foray into this little world, so this is very nice. Very nice. Thank you.
I've been doing a lot of crossovers. Just been dragging in all my podcast friends into this show because why not, right?
A happy place.
Yeah, we get different perspectives. Nice. Glad to have you, Mandy.
Well, thank you.
Just before we get started, though, Below the Surface listeners can learn more about Eclipsium by visiting eclipsium.com/go. There you'll find the ultimate guide to supply chain security, an on-demand webinar I presented called Unraveling Digital Supply Chain Threats and Risk, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. If you're interested in seeing our product in action, you can sign up for a demo at eclipsium.com/go. Alrighty, now that we got that out of the way, I think the first order of business is to talk about BIOS password cracking, which I'm sure Vlad you've done before, right? I know several on our research team we've talked about BIOS password cracking in the past, and there's easy ways and there's hard ways. Vlad, have you
Yep.
done this like recently or somewhat recently?
Yes and no. So usually for me, BIOS password cracking was, oh, hey, we just reset SMOS. Like, take out the
Right.
small battery and done. Password is no longer in the BIOS. This is a case of when this doesn't work, I guess.
Yeah. And does that clear, like, is the password stored in like a NVRAM that gets cleared when you take the battery out? Is that basically the tried and true method?
That's normally the case, but yeah, the article you're trying to mention in this case tells that it's not stored there, it's stored in actual separate flash.
Right.
So you can take out the battery all you want, password is not gonna go away.
Mm-hmm. And then so they decided to go like a different approach, and decided to start brute force cracking it with a Rust-based project on GitHub, but failed to even build. So then he asked Claude Code to write a Python script to do the brute forcing via the Windows-based HP BIOS utility, which is interesting. I'm assuming. I wonder if that's a bootable. Must be like a bootable thing. So you boot it on your BIOS utility, or if it was running directly in Windows. I'm not sure which.
It was running directly in Windows, and it had the BIOS utility apparently.
And the thing that is interesting, 6 months later of near continuous attempts at 9 seconds per try, which is very slow, by the way.
Yes.
In terms
Very,
of
very
password
slow.
brute force guessing, that is, for our listeners, that is slow. The method failed to produce a hit, and so he was unsuccessful.
Yeah, so the most interesting part of the story is that he has hardware access, like it's not a remote thing. So, or she, I'm not sure who is doing the cracking in this case. But regardless, you can get the flash contents and maybe extract the hash, which would maybe accelerate it just a tiny little bit, go from like, seconds per attempt to at least attempts per second.
Right.
So
yeah, I'm curious now what's on that flash chip. Like, what happens if you use a SPI controller and just zero out that flash?
Yeah, or I don't know, find the hash and just replace it with the hash you know. Like, what's preventing this is a interesting part, because like at 6 months of attempts, just the electricity cost of like running this might be more than getting yourself a flash program and just dumping the flash.
Right.
That's kind of what I was thinking too, along the same lines, because I feel like, yeah, BIOS, UEFI, firmware security, this is where brilliant people should be spending time. These are critical things. These are critical infrastructure.
Yep.
And yet I'm kind of confused on this. You're spending 6 freaking months to crack a $200 laptop. Like, and it's not even being done. Like what I could on the outside go is like, that's not really efficient. So is this literally just doing it for S&Gs, or are they doing it like, I'm curious on your guys' side, like, is there some other methodology here that is brilliantly working to push security forward, or was this just an expenditure of electricity, time, money because you can say you did it?
Yeah, because now I'm also thinking like you could desolder that spy chip and put a new one in as well.
I
Potentially.
feel like it's just like it's basically like there's a whole meme around using AI for various security things. Or someone thought of this one and it was like pretty easy for them to set up and do it. And they're like, okay, we tried out an AI thing for security research.
Yeah, more of an
You have to
experiment. But
be
just because you
super
can
real.
doesn't mean you should. Right? There's
Yeah.
It's going to get a headline regardless of if it's real cybersecurity research or useful cybersecurity research or not, because it's like, ooh, AI, offensive AI, defensive AI use cases.
It is. I mean, it is a testament to the BIOS password as some type of security control that does work to some level of efficiency. I do recommend a BIOS password, especially as I think about KVM systems, right? These IP-based KVMs that attach to your system. In a lot of them, you can install as like a card, or they have connectors that go onto your motherboard. So through the KVM, you can manage your BIOS just like you would in the BMC. And I'm like, some recommendations for people that are deploying either BMCs or IP-based KVMs is to set a BIOS password so that if someone does connect to it, like basically have physical access, right, is what those devices allow, that there's at least a password there that deters them.
Okay, so you're talking, so it deters. It's not bulletproof.
Right. Yeah.
Yeah, it's not always bulletproof. If you have hardware access, what you can do, you can grab yourself a programmer, dump the flash, analyze it, find where it stores password, extract the hash. Most normally, like in my experience with BIOS, BMCs, and whatnot, most of the time it's either stored in plain text somewhere, or it's like it's a very basic hash like SHA-256, depending on what you're just dumping. Like BIOS usually is hashed, BMCs usually are not, due to IPMI protocol limitations. So, and if
Wait,
you
do you
get
know
something
where?
like a SHA-256 hash, that's like billions per second on the GPU. So,
And do you know anything on the reasoning why SHA-56 is used most commonly?
performance.
Okay.
So,
Yeah, either that
so
or that.
like,
Is that what's in the EDK2 specification?
I'm not sure. You didn't check that much.
Yeah. I mean, the other thing you could do is you could reverse engineer the UE5 BIOS code and see where it's accessing and storing the password and see how it hashes it.
Yeah, and even then, like if you have physical access, nothing is stopping you from overwriting the hash, even if it would be something much more secure. Let's say some crazy soul would implement Argon 2ID in BIOS and hash using that. Well, you can just make your own Argon 2ID and just write it into the flash once you know where it is.
Yep. I would use Claude Code to decompile the BIOS and find where the code is that sets the password. Give me some, at least guide me in the right direction.
Yep. So it's like, I question the existence of why would the person specifically go through BIOS utility for this long at this slow rate.
Right. Yeah, it's the BIOS utility that's probably adding a lot of that latency, right? Because the way that it's going to access those chips is a much longer technical discussion, right? But the way software in Windows interfaces with these subsystems it jumps around a bit to like different protocols and stuff, which is probably what's introducing that latency. But like Vlad
But
saying,
how much latency?
I mean, it depends on the system, but typically it's like memory mapped IO. And there's other protocols that I can't recall off the top of my head that allow you to have access to the chips through like some other hardware or operating system subsystem. And all that is going to add latency. Whereas like Vlad's saying, just dump the chip directly. Then you can do an offline attack on it, which is much faster.
Okay.
Fine, we're still talking about password cracking. We were talking about how Mandiant released those full rainbow tables. And I started looking at how you generate your own rainbow tables. And
I was curious. Yeah.
like just a quick glance and quick research, I was like, that's really involved. Like it was asking me all kinds of questions that I didn't know the answers to as to how I wanted to create the rainbow tables. And I was
Really?
like,
Did you
oh.
look at those notes I sent yesterday? The information from Lumo when I was asking it about
Oh, no, I
generating?
looked at those. Yeah.
Because
So he had notes on it. Yeah.
right. Well, it was pretty, I thought it was interesting that on talking about like an average household connection, that if I remember correctly, it was on a simpler hash, taking one table as an example, just on 6 alphanumeric characters, that to download it would take possibly 7, I think it was 7.3 or 7.7 hours.
Yeah.
But to generate it would take like 1.1.
Interesting.
And it gave the methodology to be able to generate. So I was curious if you happened to look at that and if that was what gave you the issue.
Yeah,
You're like, I don't know how to answer this stuff.
Yeah, it's much long. Mandiant didn't publish exactly how those tables were created. And so the AI that I asked to analyze it was like, well, Mandiant didn't publish like all the details, so it couldn't tell exactly how those tables were created, like how big of a dictionary or whatever. And there was other parameters I was like, I have to research those. I don't really. It's been a long time since I've done any serious password cracking. So
Yeah, so that makes sense.
what else we got in the news? Oh, we got a new vulnerability from AMD affecting Zen versions 1 through 5 processors. This affects their SEV SNP, which is like what's the Intel equivalent? I'm drawing a mental blank now. SGX
Secure enclave, I think,
or
something
secure
like this.
enclaves. Yeah, in Intel. It's basically it's a hypervisor layer security control that, correct me if I'm wrong, prevents a host and guests from talking inappropriately or breaking out of, I should say, breaking out of their assigned memory regions. And this vulnerability allows you to manipulate pointers to essentially step out of your memory controls. Did I get that right, Vlad? Have you
Yeah.
looked at the Stackwarp vulnerability?
Not in great detail, but again, judging from what they describe, they can control pretty much execution flow, and they can inject code pretty much into a confidential VM. Like how bad it is? Yes, it's bad.
Right, but they need to be on the
So,
host operating system to inject
mhm.
into guest VMs, right? That was the
Yep.
attack flow. I gotcha.
Yep, and I presume they should have high privilege on the host's machine. I presume. I didn't read the paper in detail, but usually these attacks require pretty high privilege on the host VM or attacking, host machine, or attacking wherever the attack is from. So again, confirming this, we would need to read the paper, because if it is any user can do this attack, it's much worse.
It looks like they're in their demos. They're a regular user.
Oh wow. Okay.
Yeah, like I don't see a root prompt. Yeah, they have like
Oh
a
wow.
36-second attack. That was like the first one on their site, stackwarpattack.com. You know it's serious when the attack gets its own website, its own logo. That means it's pretty serious.
I'm glad, Paul. I'm glad to hear that these marketing activities are an indicator of seriousness to you. That warms my little heart. I'm trying to remember. It was like Heartbleed had tons of graphics. I was like, they hired a graphic designer for that one.
Right?
There's a whole marketing department. If the vuln gets big enough,
For sure.
So I want more information here. And first off, do we say SEV SNP or no?
Yeah, I'm not sure how. Yeah, it's a weird. I guess you could just call it SEV.
Sev. Okay.
Secure encrypted virtualization says a CPU extension enabling more secure separation between virtual machines and the underlying hypervisor. So you can
So
deploy so it's for a cloud. It's for a cloud provider, right? You can deploy VMs in an untrusted hypervisor environment securely, right? So the cloud is a good use case for this, right? Because you don't want tenants being able to see each other's data across VMs on a hypervisor.
and I thought, isn't this like AMD's, crown jewel of making sure there's confidential computing? And I thought I saw in some of their documentation that their pitch was like not even the hypervisor can touch your VM. But this seems to kind of fly in the face of that in every single way. So how was that missed? Like how what do you postulate? Was that the right word? We're not going to say purgatory.
Well, yeah. I think it's more for cloud environments. I think, unless you're running your own kind of cloud environment, but it's more tuned towards I'm running VMs that need to be separated from each other. So like you may have, it even says in the FAQ, like if you have an AMD CPU that supports SEV, your machine is affected, but the attack is only going to play out if you rely on that confidential in the controls that are provided by AMD SEV.
So, I mean, then to me, that means like if I'm doing quick calculations, I would assume that that's only like 20% of scenarios.
Yeah, it's probably a much lower percent. That was my
Even
take
lower?
on this one too, Mandy and company, right? Was this is for a select portion of the market, not everyone. Because like my AMD CPU probably supports SEV, but I'm not using it, right? I can use other virtualization technology, but I'm not doing the secure enclave implementation from the hypervisor built into the CPU.
Hmm.
Yep. Like for this stack to actually be effective, you need to be using the set technology in the 1st place.
Right.
And I would question in what environments it's used. Like obviously cloud,
Cloud is the
but
only
besides
besides
the
cloud,
besides
yeah.
clouds,
Right.
I'm not sure it will meet this many places. Like maybe some government agencies might be worried. Maybe some self-hosted guys who are hosting VMs might be worried. But it's like more or less fringe use case beyond cloud.
They also have, Chase, your marketing point. The very last FAQ asks if you can use the logo, and they actually provide a whole bunch of different logos in different formats for you to use.
Yeah. They want this to get covered. They
They
want
do.
us to be
They
talking
do. They
about it.
worked really hard on the marketing angle. I mean, the website looks nice. It's got a nice theme and colors and everything. Yeah, for sure.
Yeah.
For sure.
There's a marketing meta around these things for sure. Where similarly to the AI for password cracking, it's like these are the kinds of things that get attention, and attention is extremely valuable, regardless of what it's about.
Yeah, actually, to go back to what's affected, AMD in the AMD advisory that you can find, it is CVE 2025 29943. If you follow that along, you get to the AMD advisory, and it looks like EPYC processors are the ones that are affected. And that is like that's the ones that are used by cloud providers, right? It's not in like desktops and well, maybe servers, but certainly not desktops.
Because desktops don't usually come with all of those fancy features for virtualization anyway.
Right. So yeah, description for EPYC is kind of where my brain was going to. High performance multi-core server and data center microprocessor. So primarily affecting providers, which I'm sure are working diligently to apply the patch, because it hits them right where they want to put these controls, right, to separate data in virtual machines. So that was kind of an interesting one. Hey, anytime it gets a logo on a website, I feel like we have to cover it.
And it looks, I'm curious, is it always in, it's official whenever it has a black background, even when you're not in dark mode.
That's right.
It's super serious. Now, this note is, I noticed here it says also disabling SMT is an effective immediate stopgap. So if anybody is affected by this, I guess at least they can do that if they don't get the patches.
Yeah, the patches are out, and the paper will come out in Usenet Security 2026. Which that's what I was digging for on this website when I first saw it. Was I'm like, is there a GitHub? Like, can we test this? But then looking at what processors it affected, I'm like, I don't have access to one of those processors like readily available. So we will get more information and hopefully some demo code as well. But at least now,
Well,
everyone understands the
a simple
vulnerability. You can go
POC.
patch it. Vlad?
There is a simple POC somewhere in the SV artifact. Not sure what it contains. Like they actually, if you read their article, they post, or where can I send you the link? Okay, let me just drop it here. How do I find you? Here you go. Here is the link. So this is the files associated with the exploit. So they might already have published a POC. I'm just now looking at what's in there.
Oh yeah, so they did publish code. I think I couldn't find that easily on their website.
Yeah, it's in the article. If you open the PDF for Usenix 26, there is a read button on the website. And you can scroll down and you will see link to this website, Zenodo. And yeah, it contains this nice SV artifact.
Nice.
And they describe that it has simple POC, which would allow yourself to check if you're vulnerable.
Nice.
But this would be, I don't know, I'm still weirded out by that. From what I'm understanding of it, this has made it through 5 generations of this chip, right? It's been steadily vulnerable this entire time. I'm still weirded out by that, not having been found in production at any point through the different generations. Like,
it's great, and it's not the first time. I want to say there's other vulnerabilities in AMD Sev, and there's certainly vulnerabilities in Intel's SGX or secure enclaves, and there's been a series of research that basically breaks the security boundaries in all these technologies. I'm not aware of anyone exploiting it in the wild, and so this isn't traditionally also like a transient execution. This is they say it right in there, right? It's an architectural bug, not transient execution like Spectre or Meltdown. But even in all these classes, I've not seen it used in the wild unless someone else remembers a reference, but I don't see it exploited in the wild.
Yep.
Okay. And then who would benefit the most from exploiting it?
Well, it's somewhat of, I class these as like when we're talking about cloud, it's kind of an opportunistic attack, right? So let's say like as an attacker, I go create a cloud account, I spin up this technology and it's vulnerable. I got to hope that whoever's next door to me, right, my neighbors, are targets that I want to attack, right? And I think that's why we haven't seen a lot of these attacks in the wild, because it's very opportunistic. Like I don't know who my neighbors are necessarily in the cloud environment. Now, maybe I could determine that using some of these exploits, but it's very opportunistic.
Well, that brings to mind, I was talking to a dev at Dropbox, and Dropbox just migrated everything from AWS to proprietary or to locally hosted. Of course, then they also moved it to Poland. Interesting.
Yeah.
Like, okay. They also did that. And so in what you're saying, is that a portion of application, like that it had been in AWS, it's all in cloud. We're talking about Dropbox, so it's all
files, right?
Right.
Yep, juicy target. Yep. It could have been one of the drivers for them to move to on premises, but I think more so it's cost that drives people. I think security is probably second or somewhere down further on the list from cost. When especially a larger company, there was another company that makes like project management software, that moved everything from the cloud to on premises, and they had like this big party in the office, and I think the CEO and the founder like hit the button to like make the last final change that moved them from the cloud to on premises. But again, I remember reading it from that. Who is the company that makes project management software? Basecamp? I think it's Basecamp.
Okay.
I remember reading about Basecamp a few years ago in their move. And I remember security like being on the list, but not very high up. It was very much more about cost, operational costs, and the difference between running in the cloud and on premises. And so we have seen that continuing trend. Of course, whatever they're hosting on premises, could still implement the same technology. So they're not, they still are responsible. They're more responsible for security hosting it on premises in that model, but they have more control, right? If you're hosting in a cloud provider and you're concerned about Stackwarp, you have to wait until the cloud provider deploys the patch before you benefit from it. Whereas on premises, you're in a little more control. You can go, oh, I can go apply that patch from AMD.
And I will say in their migration project, it does sound very likely that they've spent more than what was projected to be saved.
Mm-hmm. Well, maybe in the short term, but they'll probably recognize the longer term gains. But again, it's more responsibility, right? Yes, now you can apply. I mean, we're going to talk about network security appliances, of course. That's the same trade-off, right? In that it's a very similar shared responsibility model. I draw this line very distinctly for Eclipsium, right? But in general, I like to classify devices because the terminology is all over the place. They call it a network edge device, a network security appliance. Like, what is it? But I'm saying that the appliances that you push responsibility back to the vendor on more so, and are trying to benefit from shedding that responsibility, are the vendors that provide you with an appliance, physical or virtual, and the vendor provides the operating system and maintains and controls the operating system, right? So when you get Cisco's been in the news for their secure email gateway and their VoIP stuff, the unified communications. So when I do the research, I ask this question, I'm like, is this product from Cisco deployed as like, do they provide the operating system and the application in a physical or virtual appliance, or is it software that I as the user can go install on an operating system that I install, maintain, control, and monitor? And that's a big difference. So when I did that research, I basically prompted AI. I said, like, I did research, like I did this magic. I prompted AI. When I prompted AI, I'm like, so how is this deployed? And AI's like, well, this is deployed as an appliance and Cisco provides you with the operating system, right? Usually that's Linux under the covers, right? We've seen usually CentOS is pretty popular, other Linux as well, and they're maintaining the operating system. And the hope, I think, from IT teams is, oh, I don't have to maintain and monitor and manage that operating system because it comes from the vendor. Very similar to the shared responsibility model in the cloud. If I'm hosting in the cloud, there's security responsibilities that I'm passing off to the cloud provider, but as soon as I bring it on-prem, now I'm responsible for the operating system. It's interesting to how we thought that was the benefit, to shed some of this responsibility, but now some of the benefit is, if I control the operating system, I can put my stuff on it, right? I can put my EDR on it, I can put my vulnerability management on it, I can put Eclipsium's agent on it, because we support the operating systems that you manage, maintain, and control. And so you have better visibility and control, but more responsibility.
That goes with most everything in life, though.
Right. But I think the hope is you have better security, right? You hope that whatever device you're getting from the vendor is more secure than you could make it yourself.
Right.
Right. I don't know if that's the every IT team's like decision tree, but certainly as a cybersecurity professional, that's what I'm like, these are the trade-offs that we have to weigh. Can we do it better ourselves, or is the vendor going to do a better job? Now, what we've seen in the past probably 3 years is an increasing continuing trend of these network security appliances having very poor security, and couple that with attackers noticing that and going, well, now that's our target, right? So we've got this perfect storm. And Chase, you've pulled all kinds of evidence that this is happening, right? This has already happened, right? That network security appliances are almost open up more risk now, right? I don't think we've ever like had the frank discussion that it's riskier now in a lot of circumstances, right? Wasn't the insurance company?
Yeah. Yeah, you found that report that opened up the floodgates to me. I didn't realize that cyber insurers were putting out these like state of the industry reports, but it was at Bay Cyber Insurance Company that put out their report that said it companies with I'm gonna cite the source so that I don't get in trouble for naming vendors. At Bay Cyber Insurance said that among their customers that filed a cyber insurance claim, among their customers, you were 6.8 times more likely to be the victim of a ransomware attack if you had a Cisco or Citrix VPNs. And then it was like 3 point something more likely if you had on-prem VPNs versus cloud or no VPN at all. And then numerous of the big reports from like the Mandiant MTrans report, the Verizon Data Breach Investigations report from 2024 and 25 indicated a big uptick in exploitation of vulnerabilities against network devices and speed of those, where in the Verizon report, the 2025 one, which is mostly data from 2024, the median time to exploitation of a newly disclosed vulnerability in a network edge device was 0 days. The median time was 0. So it's like most of them are being exploited on or before the CVE actually gets issued or they get disclosed. So it's not only that they're being targeted, but they can be exploited super quickly. And there just is no defending against that. There's these layers of challenges with you can't, as the buyer of the firewall or the VPN or whatever, you can't put your EDR agent on it. You don't have the level of monitoring. So you're not going to catch an exploit that hasn't been of something that hasn't been. You're not going to
you can't implement
anomaly. Yeah, you're not doing anomaly.
You can't implement your own compensating controls, right? They're limiting you from implementing those compensating controls. Not that you can't bypass compensating controls, but they're there for a reason, to make it more difficult and expensive for an attacker to compromise a system, right? That's the goal of EDR, patch management, the whole thing. But it's interesting too. I want to go back to a point that you said, Chase, that there's 0 days, right, from the attackers were already exploiting it. That's how the vendor found out about it and then released a patch to fix it after, like, the indicator was it's already being exploited in the wild, right? And this takes me back to like my early days working for a university, where not just my university, but many universities from like 2001 ish on we're in this unique situation where really the bar, because we were just building the security programs at a lot of those universities at that time, the bar was, can I find and discover the vulnerabilities and compromised systems myself at a faster rate than they're being externally reported from me? So when I first started at the university, the primary indicator that we were compromised came from an external report. It came from another university or law enforcement or just independent third-party reporters, and was like, hey, I'm being attacked by your system, or hey, you're hosting your 247,000 movies that are being distributed on the internet from one of your systems, right? And it was the external reporters. And we had to work hard on our security programs to just reach that tipping point where we could discover stuff better on our own and reduce that number of external reports. And everything comes full circle. Now we've got these network appliance vendors that are fixing stuff after it's exploited. Like, when are we going to start to get ahead of the problem?
It's also
it only gets worse, actually. Sorry for interrupting.
No, you go ahead.
They are slowly starting to hide their firmware from downloads behind some bars to like prevent researchers from actually digging in. It doesn't stop attackers, but it stops guys like us into digging in instead, because like if attacker is hell-bent on getting into some organization, oh hey, these guys have this FortiGate. This FortiGate costs $20,000. well, I don't care, I'm gonna buy that FortiGate. But what do vendors like us do? Because like imagine that we have 100 of those which we want to protect. All of them cost $20,000. So they're not doing a good job at defending from all of those attackers.
Yeah, it sounds like their answer is more sweep it under the rug. Don't let
Yep.
people find vulnerabilities in it so we don't run into this situation, when the real answer is let's secure up our code in applications and make sure
Yeah.
we're not delivering vulnerabilities.
Yeah, it will only get worse with this approach because it's not sweeping it under the rug from attackers. It's only sweeping it under the rug from defenders like us. And eventually what we're gonna get is exactly like the announcement that, oh, hey, your patch is actually not patching anything. So
Right.
It's like the emperor's new clothes. Like they're saying they're all secure and everybody else is going, hey, you're not actually wearing anything
Right.
over there.
Yep.
Everybody else knows it.
It does underscore an interesting point where honeypots are a way to catch what's happening now, right? So like as a security research organization, a lot of companies do this. They set up honeypots and observe the behavior, right? It's just so backwards. It's so backwards. That's where our intelligence is coming from. And we're just sitting around waiting for threat actors to exploit something to figure out what's vulnerable and what's being compromised.
Yeah, the
Yep.
new timeline. This happened a couple times in 2025. You see the like big wave of scans happening, like big internet activity that's like, oh, it looks like any sort of Palo Alto, anything that's exposed
Yeah.
to the internet is getting scanned right now. I wonder what's going to happen in like 2 weeks from now. And then there's a big wave of attacks. It's like, who could have possibly foreseen this? But it's like you can see there's like, but to have the sort of threat research be happening by attackers, and then it's like, okay, we're going to watch out for as soon as they start trying to actually use that, and then that's when the clock starts for us to start trying to do something about it. It's like we know they're going to find the vulnerabilities. When they start looking for something to attack, that means we know they have some sort of attack to do. Let's see how long it goes from when they start scanning for all the whatever management interfaces on whatever box it is. And then, but even still, like what organization can move that quickly? Okay, more fun stats. I'm a stat machine from the data breach investigation report. Those same devices, the median time for exploitation of a vulnerability on a network box was 0 days, right? The median time to patch that was 30 days. And that's the median. Lots of them take way longer. So there's a real imbalance in how quickly the different parties can act in these cases. And
I have an interesting data point on that, Chase. And then when we were looking at, I think you were on this meeting too, we were looking at basically putting ourselves in the shoes of an IT or security administrator that has to go update a network security appliance, right? So you have to know in the way the data is presented by the vendors is often, well, there's this vulnerability, it affects this operating system, and by the way, there's 100 products that use this operating system, and it's these, like, even we were looking at Fortinet, not to pick on Fortinet, but I mean I kind of will, I'll try not to, but the list like 6 different ranges of FortiOS that needs to be patched. And I think this was recent. They have at the bottom they have a link to a tool. It was like, hey, if you need help figuring out what you have, what version it's on, and what version it needs to be, they have a tool that can help you with that. So the fact that they need a tool to help their customers figure out, I don't know, I've got all this stuff deployed, like what do I have, what operating system it's running, and what version do I need to be on to remediate the latest vulnerabilities, is not an easy question to answer, right? So much so they have to have a tool. Cisco's had tools like that for a long time, right? To go, well, I've got this model, this specific model switch, and I need these features. Like, what iOS do I need, right? Which one do I need? They've all had tools to help you figure that out. So it's not that, and that's part of the reason why. My point is the remediation is much slower than the exploitation that's happening.
Yeah, 100%. And also they don't, even in a very mature enterprise that has a security team that has a process in place where they want to say, okay, we are at n-1 for our firmware versions across this fleet of whatever type of device. We have seen in the real world environments where it just isn't the case. Like, it's so difficult. You have a per vendor tool and you got a person or multiple people whose job it is to look at your tens or hundreds of different devices across all of several different vendors worth of stuff and make sure they're all at n-1
Right.
for firmware. But updating it's non-trivial to update the firmware or the underlying OS or whatever on any of those things. So it's like, even if they find out that they're not n-1 for some certain part of the fleet, it's not like they can just click and do the update. They just don't have the bandwidth for this, especially
one of the problems that I believe we ran into back in the day. I don't know what this looks like now, but this was with Cisco devices, and more so the driver, right? I think I've said this internally, but the driver for updating, the primary one is if you have a bug that's affecting production. If there's some issue with the firmware or software that's impacting production, then the like network and security teams are like, or at least the network team is like, we need to upgrade. But part of that upgrade process is, what version do I need to go to that fixes the bug that also has the features that I need that I'm using, right? Because some of the Cisco upgrades I remember were feature dependent. Like, oh, you can go to this version, but that make sure that version includes this feature because you're using it, right? If you're using a particular routing protocol. But then you have to go, if I go to that version and I'm using that routing protocol, am I introducing new bugs? And have those bugs been fixed? Because, I'm using BGP on this one, but going to that version of iOS introduces this new bug in BGP, but fixes the bug in the underlying, OS. So I don't want to say like I'm giving everyone a pass, but it's not like you said, Chase, it's non-trivial to upgrade and update these devices.
And yeah, security teams often face resistance from like site reliability guys. Like, imagine that you have an engineer who is worried about product actually running. Suddenly a security guy comes and says, okay, all our fleet of servers is pretty much in bad state because firmware is not fresh and it's vulnerable. And he's pushing this reliability guy to update all of them. And we go, okay, you want to update the entire fleet? Do you understand what will happen in production if all of them crash at once? And suddenly the process starts to drag on for maybe a year, depending on how big the fleet is.
Yep. Well, but then now there's also the scenario which makes things even worse for defenders. And this is the case. And look, no one writes perfect software. No one creates perfect patches either. So Fortinet customers are now seeing the 2025 CVE 2025 59718. Chase, I think you and I wrote about this last December. This is the one that is essentially an authentication bypass when you've got the single sign-on feature enabled in FortiGate firewalls. And Fortinet patched that in December, so I have more data. So we covered this last night on my other Pulse Security Weekly podcast, but it was just Bleeping Computer was like, this, attackers are exploiting patched versions of FortiGate. And I'm like, well, how do you know that? Like, they didn't give me any sources to back that up. But after last night, Arctic Wolf produced the evidence, including IOCs. So it is now an observable thing that attackers are exploiting patched Fortinet FortiGate firewalls for CVE 2025 59718, which again is, if you've got a single sign-on enabled, allows an attacker to bypass authentication.
Yeah, your FortiGates are now unpatched. You have to patch again soon.
You have to patch the patch. Right. And as we sit here today, I don't think Fortinet's released a patch for that. To patch the patch.
And the funniest part is that I think Fortinet is one of the OSs which tries to lock down your access to the underlying operating system.
They do.
So,
yes.
oh, the irony. So in this case, But it's not just them. It's like industry-wide problem. If it
Yeah.
would be just one company doing this, we probably could bash it. But it's not just one company. It's more than
It's all
half
of them.
of them.
Yeah, or half of them at least, right? Yeah,
Yeah.
for sure. Cisco's in the news as well. I think I talked about that. The article I have in the show notes actually it talks about both of them. And again, I mentioned these before, right? These are issues in their it was added to the Kev. This was for the Unified Communications Manager. So this is for like their VoIP deployment. So if you're using Cisco's Unified Communications Manager, also Session Management Edition, and a bunch of other things, Unity Connection. I believe that's all part of what they call Unified Communications. It's basically their VoIP systems. There is a pretty gnarly vulnerability. Improper validation of user-supplied input and HTTP requests to the web management interface. They can bypass authentication. This one's being exploited in the wild and was added to the Kev. Comes on the heels of CVE 2025-20393 Secure Email Gateway, which was the Ironport acquisition from back in the day. So yeah, I think that our audience will probably know, right? That Unified Communications Manager has a larger footprint in market share than Secure Email Gateway.
Hmm.
But both have kind of similar vulnerabilities.
Wait, so how this is saying that they're recommending they should patch their systems or upgrade to new versions in which the vulnerability has been fixed? Do you know if the upgrade costs money?
That's a good question. I'm not sure.
Hmm.
Historically, sometimes,
Right.
but major upgrades, could require hardware. If you so I was doing that with Fortinet. I was looking at so Fortinet, right? You can buy the physical appliances. Same thing with these Cisco products. You can buy the physical appliance or virtual appliance. But if you buy the physical appliance, there's like a matrix. So what version of the operating system you're on only supports this version of the hardware. Once you want to go to a newer version of the operating system, you may have to upgrade your hardware. So remediating this problem, speaking to monetary cost, Mandy, it could mean if I want to be on the latest and greatest, I got to upgrade my hardware. I got to get a new appliance, and that could take procurement, all that deployment. It could take well over a year, conceivably.
Right.
The planning, testing, the whole 9 yards. So we hope that we hope like the worst scenario is you're on an unsupported version and you can't upgrade and you're vulnerable. I don't believe that was the case with the Cisco ones. If there was a case where like you couldn't upgrade, of course, again, figuring out what versions are affected and what your upgrade path is and the affected products. I think we were talking about that this week too. Is sometimes really hard. It's not in any structured data, right? Like it's not something I can query for this set of vulnerabilities and go, hey, look, if you're worried about this Cisco vulnerability, it affects these products, and here's the versions you need to upgrade to, and here's the hardware you need to upgrade to. Like figuring that out is not easy.
Seems, yeah, complex. And it's also just annoying if it's another thing for, hey, let's just make it where it breaks and you have to pay more.
Right. And I mean, a lot of these products have been around for a while, right? Like the
Yeah.
Unified Communications Manager has version. So that's interesting. It says version 12.5, migrate to a fixed release. So this tracks. They're not going all the way back to so if you're running 12.5,
Mhm.
you're not going to get a patch. If you're running 12.5, you got to go to version 14. And then there's a patch for version 14. But if you're a hardware, you bought hardware from Cisco and it can't run version 14, that means you need to upgrade hardware. I don't know if that's the case in this product line, but it could be. Now I
Yeah.
really empathize with the IT teams.
And to be honest, it gets even worse when, oh, hey, maybe we can just patch it ourselves. But no, they are
No.
preventing access to the underlying operating system, so you are not patching that yourselves. You cannot have any compensating control.
Right. Yep. It's a great point. More the last topic we wanted to cover was, well, second to last one, because I want to talk about a recent blog post as well. Was Microsoft issuing a CVE for out of date secure boot certificates. So there's the 2011 secure boot certificates and there's the 2023 secure boot certificates. 2011 secure boot certificates, as of June of this year, I believe what Microsoft is saying is will not sign DB and DBX updates. Right? So they issued this CVE to basically say, like, you're not quite vulnerable now. It's like a prediction. Like, you're going to be vulnerable in June, but we're going to issue the CVE now so you have time to note that any Windows PC that still has 2011 secure boot certificates will be vulnerable in the future to secure boot bypasses for which we've identified like a vulnerable piece of software that was signed. So they'll issue a DBX update, but only for the 2023 certificates, not the 2011 certificates. So you could have secure boot enabled, secure boot checks out, but since it's 2011 CA, it will allow vulnerable code to run and bypass secure boot. I think that's what they're saying. They said it in very weird ways. If you read the Microsoft KB articles, and it's very strange. We were scratching our heads. Like, why are you describing it like that?
To make it more confusing.
Yeah.
Okay, so I'm confused on one point. So if they're delivering the new secure boot certificates through the Windows monthly updates, then as long as you're getting the monthly updates, in theory, you would have the new certificates, right? So is this mostly just offline rigs or air gapped systems or something?
I don't know if those updates are automatically applied or if Microsoft makes the update available and an administrator has to apply it. Because they've done stuff like that in the past. They're like, you can apply this update, but like we're not pushing it down via Windows Update. It's something you have to install because it could break stuff, right? Like if you've got a driver or something. Well, drivers are somewhat
pretty
different.
badly break stuff.
Yeah, you can badly break stuff. So that's why oftentimes they won't push it out. But also, if you're Windows 10, you are not going to get that update.
No.
Unless you just put the certificates there manually. I wonder if Microsoft has I don't know if Microsoft would document that. Because they don't want people running Windows 10. They want to run in Windows 11. But conceivably, the secure boot certificates, DB and DBX, are just variables in UEFI you can change. So you could do it yourself. Technically possible.
If the certificates aren't updated, does that basically overall make the device waste?
It makes it so I think what Microsoft wanted to say was it makes secure boot meaningless. Right? And that's why they issued the CVE. I mean, they could have just come out and said that. But like if you read the description in the CVE, I can't, and like finding it on Microsoft's site is also a chore.
They don't want to be that categorical because it still means that it will validate signatures. It's just that you can bring your own vulnerable driver and whatnot, and then bypass it. And they are hard pressed to tell it in a normal language because if they do it in normal language, they might get chased down by legal teams of other companies who are not happy with that normal language. So they have to be very fluid when they do stuff.
It could that's a great point, Vlad. It could be why they issued a CVE for this to kind of like a CYA.
Yeah.
To be like, hey, we told people, we even issued a CVE, a vulnerability, for this condition, and when you get compromised, it's not our fault. It actually makes sense.
That's kind of what I figured why they would do it and do it ahead of time.
Yeah, and this was my prediction for Windows 10 though. Like at some point, I'm like, Windows 10 is not going to get updates, and it's not going to get new certificates for secure boot, and it's not going to get DB and DBX updates, which means Windows 10 and secure boot it doesn't really mean much anymore. More work for IT teams, they're pointing out. I do want to end on kind of a fun note. So I don't know how much we've talked about this, but we have an X-ray machine in the office. And Chase, you've been in the office and seen it. Tell us about it.
Yeah, 100%.
Free healthcare is not all what it was hyped up to be.
That's right. We gotta have our own
Mandatory
X-ray
joke.
machine now.
Yep.
Oh, my
Yeah.
wrist is kind of hurt.
Yeah, no, exactly. Slap that bad boy up here. Let's give it a look.
It's not for that, right? You're not allowed to use it to image any human being, right?
Yeah, we've been putting spiders in there and then letting them free in the office. We're gonna see
Yeah.
who gets bitten.
Right.
Yeah. So far, no. Yeah, the first thing that happened with it, or the fun thing that we just published the post about, was that they X-rayed some FTDI USB UART cables, one of which was acting suspicious and was working kind of slowly or not at all for these cases, which caused them to buy a new cable. And then they were like, "We got the X-ray machine, let's X-ray it," and just looked at the the big difference between the guts of these two USB cables. And yeah, I don't know. It's fun. I mean, go to eclipsium.com/blog and check out the website. But basically, you can tell by looking if you have even marginal experience in this realm, because the old suspicious, probably a counterfeit one, is messier inside. Like it's like bad cable management, but on this micro scale where the wires are all tangly and it just looks kind of worse. But there's also a bunch of stuff that I wouldn't have been able to tell about, that I had to be schooled on. Like one of them has copper ground pores in it, and one of which doesn't, which I went down a whole rabbit hole. And it is not universally agreed upon that copper ground pores are good. But it's still pretty widely used by reputable manufacturers. But the funniest thing is that the counterfeit, or we don't actually know if it's a counterfeit. It could just be
a cheaply made cable. So I use these cables
Yeah.
all the time. Right, they're basically a USB to serial adapter. So when you want to
Mhm.
console into an IoT device or a Raspberry Pi, you use one of these cables. So USB out of your computer into the UART or serial port on whatever device that you're testing or hacking into or
Mhm.
doing some recovery on. And it allows you to talk UART protocol from USB on your computer to the device. And there are a plethora of these cables available. If you just search for, I did a FTDI USB to UART cable, and there's tons of them, and I have a bunch of them, like a handful of them, because they're cheap. You know, I like the Adafruit one. It's like $10. That one seems to be reliable, but I've gotten other ones that like they work sometimes and sometimes they don't. And now I'm starting to realize why. When we did this post, I was like, oh, that's why, because they're basically you know, cheaply Chinese made devices. There's reasons for that, right? Like the more expensive cables that are sold by DigiKey, maybe. And I'm just speculating here, but that's like the actual production run, right? So they'll go through the rigorous testing and make sure they meet a specification. Those are the $20 cables. But then second or third shift rolls around in the factory, and they're like, let's do a run of 10,000 of these, and let's kind of tweak it so it runs a little faster. Let's not do all the QA on them. And those are the ones that we sell for $2 on AliExpress or whatever, right? And I'm greatly oversimplifying it, but we saw that with batteries too. People imaging batteries. That's basically the difference. So when you see Temu and you see stuff being sold really cheaply, that's one of the reasons why they can sell it so cheaply. So when we publish this article, I'm like, oh, that makes perfect sense actually. But it's really cool to see it with the X-ray machine, and I love how they presented the blog post. You can see the two images as you scroll through the post, and they're like, all right, tell me which one is the I don't know if you say counterfeit. It's not Counterfeit's not the
Uh,
right term.
the worst one. It might be a counterfeit, or it might just be kind of a cheap bad one.
The one not built quite to spec versus the one that is built to spec. And so you get both images, and you get to look at those before you get the answer as to which picture is which. And I'll be honest, I got it wrong, and I go back and I learned some stuff too from this post, Chase.
Yeah, thank you. Shout out Eclipsium research team for that one. Super fun. And they're doing more. That was a fun one. But they're doing they're doing some pretty serious research.
They're doing
with,
serious, yeah.
X-ray
That was
machine.
just a fun one. So we have an
It's
X-ray
just a
machine.
cool thing to have. We'll do more posts on
Yeah.
the way.
We
Absolutely.
sometimes do interesting stuff as well,
Right.
not just
right.
X-ray.
This was just a kind of a fun one. Yeah.
Yeah.
Well, I want to, we're running short on time. I want to thank everyone for participating today. I want to thank everyone for listening and watching this edition of Below the Surface. We'll see you next time. Over and out.
Fine.